So let's jump squarely in to the first decade of the 1800s when new chemical elements were being discovered at breakneck speed. So it was an exciting time in chemistry. And let's sort of officially reject or set aside the classical four-element theory. While it had amazing value and served alchemists and chemists for centuries, almost millennia, it was insufficient in explaining some basic things like chemical reactions where chemicals or elements combine in fixed amounts. So we're in this new era in chemistry where the universe is not made up of just four elements. It's made up of these increasing numbers of chemical elements. But this led to sort of an uncertainty or an unease in the chemistry world because you can kind of guess or imagine that all chemists and all scientists believe there's like a faith that scientists have that there's got to be some order, some set of laws that govern our universe. And with all these new elements kind of emerging, there was no clear order that was seen. So that's actually where we are right now, is can we make sense of all these new chemical elements that are emerging? And so specifically there are four questions that come up. One is, where are these chemical elements and can we go find more? And this is what we'll actually discuss in this chapter. Two is, are there relationships amongst all these new elements that were being discovered? So is there some connection behind all these new elements? Three is, where do the properties of the elements come from? So what makes titanium titanium, gold gold, what makes hydrogen hydrogen, etc. And the last question that came up, and we touched on this in chapter 1, is why are compounds, which are made up of elements, why are the properties of compounds so different than the properties of the elements that make them up? And can we find some relationship between the properties of elements and the properties of compounds? So these are four questions that emerge in this new era where the universe is not made up of four classical elements, but it's made up of increasing number of chemical elements. So this is where we are. We have these four questions, and let's see in this chapter if we can take on the first question and see if we can discover a couple of these elements. So where are they? To be sure, for thousands of years, a handful, about 13 elements, were known to humans. So copper could be pulled directly out of the earth in its pure form. Gold could be pulled directly out of the earth in its pure form. A few other elements could be extracted or purified out of rock ores through just heating them. So mercury is an example of this. But for most of human history, all the elements we know of today, or most of the elements we know today, were locked up and hidden in rocks, in minerals. The first leap, the big leap forward, at least in the West, was with Antoine Lavoisier, who did build up a table of elements that consisted of 30 elements. Not all of these were proven to be correct, but he was the first in the West, at least, to start amassing tables or lists of these elements. And certainly there was a suspicion, like I alluded to, that there were many, many more. And so the idea was they got to be locked up inside of rocks and ores and in dirt somewhere, and maybe even in outer space. So this was the suspicion, but little headway was made until 1799. What happened in 1799? Alessandro Volta, which we've mentioned to him before, an Italian physicist, biologist, chemist, invented what we now call the battery. And it was discovered, and we did a little bit of this in course 1 with the electrolysis of water, that if you add electrical power to compounds or substances, pops out pure elements. So this is where we're going to start in this chapter.